Hi everyone. So welcome to the class. So we were discussing about sentiment analysis, how to conduct sentiment analysis, right? So in the last lecture we talked about what is this NRC lexicon, right? How it was prepared. It has a long list of words so which are used for text analysis. We talked about the sentiment analysis using this NRC lexicon and how to apply it. So we went through a application process. So where we tried to see through an example how to conduct a sentiment analysis, and today we will be moving ahead with the same theme of sentiment analysis, but today we will be talking about deep learning algorithms, right? So what are deep learning algorithms and why deep learning algorithm is needed for sentiment analysis? So it's an improvement over the NRC lexicon, so the lexicon based analysis. So but what is it exactly? So we will talk more about it today. So welcome to the class again. So what is this evolution of sentiment analysis? So when I am talking about sentiment analysis, so in the early stages, researchers used lexicon based approaches. So basically a dictionary which consists of predefined words, right, which were labeled with sentiments like scores like positive, negative or neutral. There were 8 emotions. So these methods were very straightforward because they simply summed up the sentiment scores of individual words in a text to determine the overall sentiment. But this technique had several limitations also. So, for example, the first limitation is the lack of context awareness. Now, they struggle to differentiate meanings based on context. For example, you see, human beings are very complicated, right? So, when we use the same word, at least in certain languages like English. One word is used in different kind of meanings, right? And depending on the context. So, example, you see here, the word cold could mean low temperature, right? So, or emotionally distant, so which is negative, and low temperature is neutral, for example. So, lexicon based methods often fail to recognize this distinction. We say, no, the temperature is very cold outside, and sometimes we say this person is very cold in is in nature, right? So, that means he is emotionally not affected, or he is a very emotionless or a less emotional person. Okay. So, such kind of context is difficult to understand in the NRC lexicon approach. Then it is also difficult to handle sarcasm or negation. Okay. So, sentiment lexicons assign fixed scores to words, making them ineffective when sarcasm or negation altered the meaning of it. So, for example, you see, oh great, another Monday. Now, a lexicon based approach might classify great as positive, and it might miss the sarcastic tone, which might be, for example, on Monday morning, you might be, when you are going to office, you are saying, oh great, another Monday. So you are sarcasm, there is a sarcasm. So we are trying to actually criticize, but then because the word great is there, the dictionary meaning takes as a positive word, right? So the sarcasm is missed here. The third point is, it struggles with domain specific language. Now these approaches were not adaptive and performed poorly in specialized fields like finance or healthcare. Now, for example, in a financial context, when we say bullish market, right? So it's a very positive, normally positive. So it means a rising market, a growing market where people have very positive sentiments. But on the other hand, crash, which is normally negative, can refer to a temporary dip. It might not, if bullish is very positive, crash might be negative, but it's only a temporary dip. So sometimes the domain specific understanding is also poor, right? So to counter these challenges that you are following, that you are facing in the rule based approach of sentiment analysis with this NRC lexicon, can be dealt now with better approaches. So today here we will be talking about how machine learning solves the old problem, but introduces new issues that should be managed. So, for example, if NRC lexicon was not able to comprehend a few things, but it was simple, right? So, but the point is, now we are talking about that we need more accuracy. Our model should be more accurate, better. So, for that we need a machine learning approach. Okay. So, here we talk about supervised learning in sentiment analysis. Now, ML models, which are basically the machine learning models like naive and support vector machines SVM, commonly which are used for the sentiment classification. These algorithms require labeled data sets, right, where text is tagged on a positive, negative or neutral, right. For example, I think I have explained naive Bayes is a probabilistic machine learning algorithm based on the Bayes theorem, right. But suppose you want to separate two groups of points in the best possible manner, right. So, here we use support vector machines, right. Support vector machines, what it does is basically it tries to classify in a much effective manner. Now, example, you see this example. If we want to sort apples and oranges based on weight and color, let us say, right. So, SVM will help us find the perfect line or curve that separates them with the widest margin, so that future apples and oranges can easily be classified in a right manner, right. So, for example, you see when I am talking about weight and color, maybe the weight of an apple could be 100 grams, could be 200 grams or 150 grams, right, 3, let us say 3 points. Similarly, an orange could be also 50 grams, 100 grams or 150 grams, right. And we can have maybe colors also in red, yellow or some color, right, green. So, oranges also can be the same color. So, what it does is basically it makes a very up to the level the best possible classification. So, it differentiates in the best possible manner, so that there is clarity, there is clear demarcation between the apples and oranges, right. So, it is generally used for email spam detection, face recognition, cancer detection, etc., right. So, such kind of examples where you want to detect through the face, for example, by the jawline, by the eyes color and all, whether who would this person be or what kind of person this would be. So, from email, for example, through the kind of the origin of the email or the person who is sending or the context of the mail, you can also say whether it is a spam or not. So, businesses use SVM to classify customer reviews as positive or negative based on the keywords basically. So, some more thing is that support vector machines, right, versus naive base, if you see, support vector machines have certain advantages. Okay. So, the features can be correlated, where in naive Bayes the features cannot be correlated, right. So, they are basically independent to each other, right. And as I said, it struggles, it is more accurate. Which one? SVM is more accurate and naive Bayes is less accurate in comparison. Okay. Handcraft features for improving accuracy. Now, what are we saying? Now, traditional models relied on manually created features to detect sentiment analysis or to predict the sentiments, right. So, we used, for example, n-grams, right. If you remember, we have done it, right, sequencing of words, for example, n bigram, unigram, trigram, right. Then we also had TF IDF, so term frequency, inverse document frequency, which identifies the important words and also gives us a score. Then bag of words, which converts text into numerical representation, right. Then part of speech tag, which identified parts of speech, for example, the adjectives like amazing, which is signaling positivity. So, basically, these are some handcrafted features. So, you are making some changes manually to improve the accuracy. Okay. But there are challenges when you are trying to do something on your with your manually. So, it will have some challenges. What are the challenges? So, these models have challenges of scalability. So, handcrafted features is labor intensive and it requires domain expertise. So, for example, if you want to escalate it or make it big, so there would be an issue because it is highly labor intensive and you can't do that. There is a limitation. Then second problem is limited adaptability. Now, features designed for one domain may not work well with another. For example, do you think movie reviews are same to product reviews? Will the same features work equally in the similar manner? May not be, right. So, for movie reviews, it might be a different ball game altogether in comparison to the product reviews. Okay. So, a model, for example, you see a model trained on restaurant reviews might associate spicy with positive sentiment, right. But in a healthcare review, spicy could indicate a problem. Example, spicy food caused stomach pain. So, just imagine the two contexts. Okay. So, these are the challenges. Okay. Then there are performance issues also because of the limited or imbalanced data. So, ML models, machine learning models struggle with when the data is small or certain contains class imbalance, right? So suppose there are more positives than negatives. In such a case, if there is a discrepancy in the score or the numbers, then also it will have a problem. So they fail to capture complex linguistic phenomena such as negation, long range dependencies. So for example, I don't like the movie, right? I don't like the movie. So traditional models might misclassify it as a positive because of like. So because the word like is there, it might take it as a positive, but then it says I don't like the movie. Okay. Similarly, for long range dependencies, despite the hype, the movie was quite disappointing. What is saying? Despite the hype, the movie was quite disappointing. So early words suggest positivity, but the actual sentiment is negative, right? So sometimes these are some challenges that you have to face. Now if a data set contains mostly positive reviews, the model may overfit and classify everything as positive, so failing to detect some negative reviews. This is like a teacher teaching in a class and finds that a good student, generally who the teacher feels is a good student, if he has written something negative also, something wrong also, he doesn't understand because the model is overfitting. He ignores it because he feels the student cannot do wrong because he is a good student. And similarly, the opposite goes true for a poor student. So if a poor student, sometimes he has done well in particular subject, still the teacher might not be able to judge it well because the model is overfitting, it is extremely negative. Okay. These limitations led to the rise of deep learning approaches. Now because we saw these are having their own limitations, so deep learning approaches have been developed which automatically extract features from the text and handle complex linguistic structures better in a more efficient manner, right? So what are those deep learning techniques? So what is deep learning basically? Deep learning is a subset of the machine learning that uses artificial neural network, so ANN, to learn patterns from large amounts of data, right? So what it is doing? It automates the feature extraction and excels at tasks like image recognition, natural language processing and speech recognition, right? So you have certain architecture, for example, which are called transformer architectures like BERT, GPT, which are used. So what is BERT? Bidirectional encoder representation for transformer, which was made by Google, or generative pre-trained transformer, which was made by GPT, which was made by OpenAI. So what it basically, these are advanced deep learning models for NLP. You can have for other areas also, but for NLP, these are the advanced deep learning models. It uses self-attention mechanisms to understand entire sentences at once, right? So as we said, Google search, Chat GPT, AI based content generation, these are some of the examples for it. Okay. Now what is the impact? What is the impact of deep learning on sentiment analysis? So unlike the traditional machine learning tools or models that require manual feature engineering, right? Deep learning enabled end-to-end learning, where the model automatically extracts relevant features from the text. So it is like the model is training itself, is learning itself, right? So it is a process of continuous learning for the model, right? Advanced neural network architectures such as LSTMs, long short term memory networks, this captures sequential dependencies, making them effective for understanding word order and context, which was it was a limitation in the earlier energy sentiment analysis, right? So this problem is taken care here. And then you have transformers which use self attention mechanisms to capture relationships between words regardless of the distance in a sentence. So sometimes, for example, you look at this sentence, I loved the movie. I loved the movie, but the ending was disappointing, he says. So an LSTM might struggle to associate. So transformers are in improvement, improved architecture over the LSTMs, right? So the LSTM might struggle to associate disappointing with ending, right? If the sentence is long, but a transformer can capture this dependency more effectively. So what are the in deep learning, what are the things we have? So we have contextual embeddings, self attention and transfer learning, right? So traditional word embeddings like word to vector assigned fixed meaning to words. So that is where the whole problem was coming up. So you had a fixed meanings, cold means cold is this, right? But then cold could be different for ice, and cold or water or cold could be different for a person, right? So, which led to this misunderstanding when it went to different contexts. So, the police looked at the thief with a cold look, right? So, here does it mean that he was happy or not very angry? No, rather it makes the opposite meaning, right? So, BERT bidirectional encoder representations from transformers introduced these contextual embeddings. So, this context related problem was solved by this, meaning that the representation of a word changes depending on the surrounding words. So, what is the surrounding word? The surrounding word could be wind here, or the surrounding word could be person. So, if it is wind, the word cool or cold has one meaning. If it is a person, it has a different meaning. Then self attention also allows BERT to consider the relationship between all words in a sentence, helping to disambiguate the meaning, right? Now, let us look at the phrases. The movie was not bad. The movie was not bad. So, positive, right? The movie was bad. Negative, right? A traditional ML model might misclassify not bad as negative because it focuses on the word bad, right? But using self attention understands that not bad has a different sentiment from bad, leading to a more accurate classification. So, basically what we are doing, we are constantly evolving, we are constantly improving. So, today there might be, tomorrow there might be even better models, right, which will take care of even better things. Maybe then speech might be taken care of, image might be taken care of, and all taken together they might give a different meaning, right. Today we are talking about text now, at this moment we are talking about text, right. Then transfer learning in deep learning. So, before deep learning, training a sentiment analysis model required large, labeled data sets. But transfer learning changed this entire thing by allowing pre-trained models, so like your BERT and GPT, to be fine tuned on smaller domain specific data sets. So, this was a big advantage. So, you do not require now a very large data set as earlier. So, you can today work on smaller domain specific data sets. So, this made high quality sentiment analysis models accessible even when labeled data sets were limited. Okay. So, example, you see a general BERT model trained on internet text, right, can be fine tuned on medical reviews to understand sentiments in healthcare related discussions. Okay. So, because on the internet you have so much of text, and using this text, right, you can make those reviews, understand those reviews better. So, example, the treatment had minimal side effects. The treatment had minimal side effects versus the treatment caused severe discomfort, right. So, now it can be easily understood, it can be better understood, because now we understand that the treatment had minimal side effects is more positive, right. The treatment caused severe discomfort is more negative, right. So, these kind of understandings improves, right, with this transfer learning. But it is not that everything is rosy. All, the deep learning has no limitations, it has some challenges also. So, the challenges are computational demands and data requirements. So, as it says, despite the advantages, deep learning models come with significant drawbacks also. So, first is computational cost. So, training a transfer based model requires powerful graphic processing units, or which are called GPUs, as you must have heard of NVIDIA, like companies making it, or tensor processing units, which are large scale data sets. So, tensor processing units, basically they are used, they are even powerful, right, they are even powerful. I think Google is the one who has made it, and they have more applicability, right. But the challenge is that it requires, both of them, they require large scale data sets. Then you have resource constraints. So, displaying these models on mobile devices or low power applications can be challenging, right. Let us say a startup wanting to build a real time sentiment analysis application or app for customer feedback might struggle due to the cost of running a full scale transformer model, right, leading them to opt for smaller models like distill BERT, a compressed version of the BERT. So, what it is basically saying, now sometimes because of the kind of approach you are having, right. So the cost of running on a can differ because a high end computer with extra power, right, power backup and all, processing speed and all, will be different to a mobile kind of a device. So if you want to run a similar, it might not work, right. So that these are the challenges you have, right. So now we will perform sentiment analysis using a deep learning model. But before that, let's understand something which is very important, called zero shot learning. What is this zero shot learning? So traditional models, right, the machine learning and deep learning models require task specific training with labeled data sets. But zero shot learning is changing this by allowing a model to perform sentiment analysis classification without direct training on that task. So this is a big improvement, right? So which is, we will see in the future, right, what it is exactly, how it is working. So instead it relies on pre-trained language models to infer sentiments based on natural language understanding. So let's take look at this example. Instead of training a model like sentiment labeled tweets, a ZSL or zero shot learning, right, model can determine sentiment using a prompt like, is this text positive, negative or neutral? The model then evaluates the text based on its general knowledge from pre-training. Okay. So how this ZSL works? So instead of treating sentiment analysis as a classification problem with predefined categories, right, ZSL models frame it as a natural language inference task, right. So this means that the model predicts whether a statement logically follows from a given text or not. Okay. So example, you see, using a ZSL model, a GSL model like BART large meta. Now what is this? So input text, the input text is, I can't believe how amazing this experience was. What is the prompt? This text expresses positive sentiment, right? What is the model output? Not true. This sentence is correct. Okay. This approach allows the model to work without explicit task specific training and adapt to new domains effortlessly, right. The advantages are cross domain adaptability and implicit sentiment detection. So since ZSL models are not confined to a single data set, they can generalize well across different domains, right, and adapt to various contexts. So it is only asking through a prompt, no, whether it is right or wrong, including social media, reviews and even legal or medical text. They also excel at implicit sentiment detection, meaning they can recognize figurative languages, sarcasm or some kind of emotions better than traditional models. For example, you see text, oh great, another Monday. So a traditional ML model will say great as positive, right? While ZSL understands sarcasm from the context. So this is the advantage. But as I said, everything has a limitation. It is sometimes bias and low resource language issues are there, right? So what is saying? So bias from pre-training data. So since these models are trained on internet scale corpora or the data, they may inherit some social biases. So for example, social bias could be favoring Western sentiments, right, or talking about more about technology based, technology driven sentiments, right, or let us say, so these are some kind of more kind of social biases. So we have certain social biases, no, which are not very right or wrong, but there are some biases. Then struggle with low resource language. Since most pre-training data is in English and major global languages, ZSL models may perform poorly on less represented languages, right. So for example, you see a ZSL model trained mostly on European and English language may misinterpret sentiments from language like Xhosa or Khmer, where sentiment cues differ, right. So these are some small challenges, but largely if you see, it is very powerful, very strong, because that is largely taking care of the major issues. Okay. Now we will introduce a deep learning model by which we will perform sentiment analysis using zero shot learning approach. So here we will open a site which is called Hugging Face. Okay. So this is very useful. So this is very, let me open it, Hugging Face. Yeah. So you can also go to this website. This is a very good website. So it will teach you very nicely about how to do this zero shot classification, what is this all about. So, look at this. So, for example, this one we are talking about Facebook's, which is Meta, right. So, basically, so these are some of the things, like you can see here the codes are also there, you can see these codes. Okay. So, BART basically, which is used here, is basically called as bidirectional and auto regressive transformers, right, and it is a deep learning model based on the transformer architecture. It was developed by Facebook AI, which is Meta, and is particularly useful for text generation, summarization and natural language understanding tasks, right. So, how BART works? Now, there is a pre-training approach. BART is trained using a denoising autoencoder framework, meaning it learns by corrupting input text and then reconstructing the original text. So, this helps the model develop a deep understanding of the language structures and the semantics. Okay. So, BART basically is an improvement, right? Is an improvement. Okay. The architecture, it combines BERT and GPT style learning. So, BART is a combination of, you can say, BERT and GPT. So, like BERT, it encodes bidirectional context. So, understanding relationship between all the words. Like GPT, it decodes auto regressively, meaning it generates coherent text step by step. Okay. So, what are the applications in NLP? So, it is used for sentiment analysis, as we are talking about, text summarization, machine translation and text generation. For example, chatbots, paraphrasing, they are some of the applications. Why is BART considered a deep learning model? Now, it uses basically transformer layers. So, one reason is that it requires large scale pre-training on the GPUs and TPUs for effective learning, and it learns complex linguistic relationships. So, for these features, for these conditions, it is called a deep learning model. Okay. So, this is the reason why BART is considered as a deep learning model. Now, after this, what we will do is we will go for performing a sentiment analysis using this deep learning model. Okay. Now, let us start this exercise. It will be a good hands on experience for you. So, here what we do is, as usual, we start with the first step. So, which is installing the required packages. So, the package we are installing here is pip install transformers torch. Okay, as you can see here. Okay, right. So, what is the purpose? The purpose is it installs the transformers library by Hugging Face. So, that is why I showed you that site, and PyTorch torch basically transformers provides the trained models like BERT and BART for NLP tasks, and torch is the deep learning framework to run this used to run these models. Okay. Then the second code is pip install upgrade torch, this one, the entire, you can read it, right. So, what is the purpose of this code? It upgrades the PyTorch and related libraries to the latest CPU compatible versions. So, because there is a upgradation all the time, so it brings you to the latest version. Details, it specifies the PyTorch package repository for CPU only installations. Okay. So, no GPU support needed here. The third code is pip install upgrade transformers accelerate. Now, the purpose of this is to upgrade transformers and accelerate to their latest versions. And details, accelerate here, a library by Hugging Face to optimize model inference. Okay. So, example, mixed precision, parallelism. Then the third, the next, code is importing the pipeline. So, from transformers, we import the pipeline. Again, the purpose is to import the pipeline function from the transformers library, and the pipeline simplifies using pre-trained models for tasks like text classification, translation, etc. The next code is loading the zero shot classification pipeline. So, as you can see here, so we have written the code. Now, what is the purpose of this code? It loads a zero shot classification model from Facebook, like for with BART large MNLI. So, this, it, as I said, zero shot classification, the task type, right, classifying text without task specific training. So, BART, and as it says, a BART model fine tuned on a multi-general language model inference dataset, which is effective for the zero shot tasks. The next code is categories. So which we want, like positive, negative, our emotions and the sentiments, right. So it defines the candidate labels, categories for classification, and these are the emotion sentiment labels. This model, the model will predict how likely the input text belongs to each. Okay. So at the end of the sentiment, we want these things, right. These are the most important. So next we will go to this, once we have taken this input text, so now we will classify the text. For that we have this code, right. So now we have taken around several reviews here. So once we have given the code, this code you can highlight result is equal to classifier text, this code, right. Now it will, let's run this, right. When we run and we print the results, now let's see what we are getting. So if you see, let it run. So it will give us a score. Yes. So this is the score we want. So negative 0.7823, positive 0.5131, trust 0.3425, surprise 0.2341, then anticipation, fear. So there is very little fear, anger and joy, and even disgust and sadness. So the highest is negative, very high, positive also high, and trust is to high to some extent, right. So this gives us a clear understanding of what, how to classify and what is the emotions behind the text. Okay. So once you have these emotions and the sentiments, you can make your own analysis interpretation out of it. Now what I am doing is I am just changing the text. I am taking a few, I brought in some more review statements, right, text, and I will change them. So for example, let us take this text and copy it over there and run it again. So let us see what is the change in the emotions and the sentiment, and let us run it once. So if you are running this, you see now when the sentence has changed. Now this new sentence says the product exceeded my expectation with exceptional quality, but the customer support was unresponsive and unhelpful when I needed assistance, right. So here the surprise is 0.6 is the highest, positive is 0.45, anticipation is 0.233, and negative is not much, only 0.09, right. Although there are some sentences, some words which are negative because unresponsive, unhelpful are negative, but maybe the model needs more improvement. Let us take another example. So let us take another line, maybe this text we will see how is it really matching to our human thought processes or not. So let us put it over there and see what is the change in the result. So this is saying that the app is easy to use and offers great features, but the performance often lacks, especially when I try to use it for multiple tasks at once. Okay. So here negative is 0.8 through 83, which is significantly high. Surprise is 0.17, and other things are as it is given to you, right. So here the performance maybe is the most important, because the performance is lagging, right. The whole sentence is being treated as a negative with a negative sentiment. Okay, let us take one more, maybe some, this is one which we take. So it says I absolutely love how sleek and stylish the product looks, but unfortunately it broke just after a month of use, which was very disappointing. Technically it should be very negative, but let us see how the model is understanding it. Okay, let us see that. Let us the score come 9.76, 0.97. So that is why it is, we can say it is a very negative sentence. So very clearly it is understanding. So that is why we can say this model is being is running quite well, right. Our text analysis results are showing a great improvement. So this is how we run the sentiment analysis. So deep learning models are an improvement. So we stop here, right. So we have done a deep learning approach for text analysis or sentiment analysis, and with this we can understand that deep learning models are obviously an improvement over the traditional models, and they will be very helpful in the coming days because the evolution is on, right. So the process of improvement is on. So every model will be slowly improving, right. It is not that it is a final product. So this improvement process will go on, and with more and more new maybe kind of data sets which will be brought into the picture, maybe the models will have to be more complicated, more have to work harder. So and the accuracy levels have to be better, otherwise the point of doing sentiment analysis will be lost. So I think with this we have understood today what is deep learning, how deep learning is helping you, And with this, I'll close up today's talk. And in the next class, we'll meet with something new. So, till then, take care and thank you very much.